In this video, we'll be talking about base 16. Let's think about the number 1, 0 in base 16. The 0 means we have no units, but the 1, since we're base 16, represents one group of 16. This presents a challenge because when we have 10 objects, we cannot represent it with 1, 0 because 1, 0 in base 16 represents 16 objects. So when we look at the numerals that we use, we start with 0 through 9, but we can't put 10 next because 1, 0 represents 16. So we switch over to letters A, B, C, and D. So 9, and then comes A, B, C, D, E, and F. Where in base 10, this would correspond with 10, 11, 12, 13, 14, 15 different objects. Let's see what this looks like with unifix cubes. Let's start with 9 objects. When we add one more object, again, we're going to have to write down the letter A when we're working in base 16. When we think about place value, the location of the numeral indicates its value. So we really need to be careful to only write one symbol in each place right there. So as we move forward and we get to the letter F, that's our last symbol that we have to use, which corresponds in base 10 to the number 15. So adding one additional unifix cube, we will have created a full set. So we put them together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we write down one group of 16 and no units. We can keep going, of course, and add an additional unit, and then we would have 1, 1 in base 16. Let's try a few examples. Let's look at what comes after the number 1, 9 in base 16. Well, when I look at my list here, after the 9 comes A. So our next number becomes 1A in base 16. It's really hard to get out of the base 10 frame of mind because we always think of rolling over to the next group after 9. But in base 16, we roll over to the next group after F, as in the next example. So 2F, base 16, F, what's the next numeral available? Well, I don't have one. This is going to make adding one more is going to make a complete group of 16. So I'll have one additional group of 16. The 2 becomes a 3, and now I'm to 0 individual units. So after 2F comes 3, 0 in base 16. Similarly, looking at what becomes before 5, 0 in 16, if I take away from one of those groups of 16, then I'm going to come down here and have F. So I'll have broken up one of my 5 groups of 16. So now I only have 4 groups of 16. And that full group of 16, when I take one away, I'm left with F objects. So 4F in base 16. Base 16 and some of these other bases might seem really strange to you, but if you were a computer programmer, then you would be familiar with base 16 and base 2. Base 16 is also known as the hexadecimal system, and if you ever saw the movie The Martian, the main character gets stuck on Mars, and his system to communicate with scientists back on Earth uses base 16. Base 2, or the binary system, is how we communicate with computers, and it just uses the numbers 0 and 1. If you've ever seen the cartoon Futurama, the character Bender is a robot, based on computers, and periodically zeros and ones pop up as he's trying to communicate.